This problem says locate the z-score of negative 0.99 on the normal curve. Find and shade the area to the left of the z-score. Alright, first thing we'll want to do is we'll want to make ourselves a z-scale and just mark off some of the important points here, like 1 standard deviation above the mean, 1 standard deviation below, maybe 2 above and 2 below as well. Okay, now we want to find the boundary, the cutoff. That's the z of negative 0.99. Now negative 0.99 is awful close to negative 1. So that's where we want to make our boundary. Okay, now we want to shade all the area to the left of that cutoff. Okay, we can even mark that z. And we need to find the area now from the table. So I'll go to the tables. I want to look up a z of negative 0.99. Here's negative 0.9. And the 9/100ths is actually the one right next to it, this column. So we're looking at 0.1611. Now you can call it P is one letter that we often use for these areas, which stands for probability. And we also can write it in the the standard notation, which is the probability of a z-score being less than negative 0.99 is approximately 1.611. Okay, and that one's done. Next, let's try to find the z-score of 1.06. And we'll find and shade the area to the right of it. So once again, just like normal, we'll start with our important markings just to give ourselves a little scale to work with. Okay, 1.06 is awfully close to 1, a little bit beyond it. Okay, and then we want to shade the area to the right. So it's a right tail. Let's go to the table, and we're going to look up the cumulative area first. Alright, here's our 1.0. We need to attach the 6/100ths onto that. So trace it down, find the intersection. 0.8554. Keep in mind though, 0.8554 is the left tail. So we have to do that calculation where we find this area by doing 1 minus 0.8554. Okay, that's going to be 0.1446. Okay, to write it in the proper notation now, the probability of a z being greater than 1.06 is approximately 0.1446, 14%. All right, and our last one here, we want to see if we can squeeze in 3 standard deviations. Okay, and let's shade the area between a z of -2 and a z of 3. Okay. First thing I'll do is I'll look up what is the probability of a z being less than 3. Let's find that out first. .9987. Now let's look up what's the probability of a z being less than -2. The left tail here. Here's -2. Put it together with the 0. You get 0.0228. Okay. What we're going to want to do here is we're going to want to subtract 0.9987 minus 0.0228 0.9759. Okay, now let's see if we can write it in the standard notation here. The probability of a z being between -2 and 3 is approximately 0.9759. That's the green area here.